Good afternoon, learners, wherever you are, whether you are learning online or in a physical class. I'd like to welcome you to this lesson in which we are going to be discussing the topic called electromagnetic waves. Electromagnetic waves, it's a Form 4 topic in Msce physics. Okay, so my name once again is Mr. Lola. Remember that you have the privilege of accessing our content, our lessons, by simply registering with us for online lessons under the umbrella of Black Slides Tuition Malawi. So you can call us or text us on WhatsApp, or simply send us an email. On the email given here, we should be able to come back to you. This is very important for you to do. All right? You can also do yourself some favor as well as us, that as if you want to get updates, on the uploaded content or subject matter, remember to subscribe to this channel so that you should be receiving regular updates as lessons are being uploaded in a video format. You should be receiving updates. So to do that, you have to subscribe, you have to comment, and you also have to like our content. So welcome to the lesson this afternoon. Once again, my name is Mr. Lola. Right, so maybe for a starting point, let us quickly define the electromagnetic spectrum. What is the electromagnetic spectrum? There's a question that appears in papers asking learners to define, or candidates to define, the electromagnetic spectrum. For the sake of this lesson and this level of learning, which is the Msce learning level, we shall define the electromagnetic spectrum as a continuous spectrum of waves, which includes the visible spectrum. So we are saying it's a continuous. The word continuous is key to this definition. All right, so we are saying the electromagnetic spectrum is a continuous spectrum of waves, which includes the visible spectrum. All right, okay. Spectrum, I think we're going to replace the word spectrum for now so that we don't repeat it in the definition. This word is used to mean band. So we can define therefore the electromagnetic spectrum as the continuous band of waves. Even if you put full stop after the word waves, no problem, it's still complete. But we are emphasizing that this definition includes the 7 colors of a rainbow. The 7 colors of the rainbow collectively are called visible spectrum, or simply visible light. Right, so the electromagnetic spectrum has 7 waves which are in a continuous band, the band called electromagnetic spectrum. So in case they ask you, name any 2 parts of the electromagnetic spectrum, you'll mention gamma, X-rays, UV radiation, or sometimes known as ultraviolet radiation, visible light, infrared, microwaves, and radio waves. So these are the parts of the electromagnetic spectrum. All right. Now, the electromagnetic spectrum is divided into 7 bands, like what I just mentioned earlier on. and these can be arranged in order of decreasing wavelength. Remember, wavelength is the distance between two successive crests, or the distance between two successive troughs of a transverse wave. Right, so we can arrange the 7 bands in order of decreasing or descending wavelengths. So in order of descending wavelengths, the first one is radio waves, followed by microwaves, then infrared, visible light, ultraviolet rays, X-rays, and gamma rays. All right, so starting from longest, what it means here is that as you move from radio waves to microwaves to infrared, the wavelength keep decreasing. So in this case, in case you have this mix-up of these waves, and they ask you to state the electromagnetic wave with the shortest wavelength, that means it's gamma, and the one with the shortest wavelength, or longest wavelength, is going to be radio waves. Or sometimes you're going to have this mixed up for you to arrange them in order of decreasing wavelengths. So remember this order very well. An easier way to remember this in this order is to just follow this sentence here, which says rabbits met in very unusually expensive gardens. All right, this is just a way for you to remember the order. So rabbits met in very unusually expensive gardens. That means you have arranged all of them in the order of their decreasing wavelength, starting with radio waves going down. But there are times when you also have to know that moving from gamma to radio waves upwards, this means that the wavelengths are increasing. So in order of increasing wavelength, you can start with gamma, X-rays, UV radiations, ultraviolet, visible light, infrared, microwaves, and radio waves. That's in order of increasing wavelength. Okay, so whichever order, make sure you know this. So we are saying an easier way to remember the order is to form this sentence, or to be able to say this sentence. Rabbits met in very unusually expensive gardens, starting from radio waves to gamma rays. R stands for radio waves, and the M for micro, I for infrared, V for visible light, U for ultraviolet radiations or waves, X for X-rays, and the G for gamma rays. Okay, so always remember this order. So this is a list of electromagnetic waves in order of decreasing wavelength. All right, so we can also list the radiations in order of decreasing frequency and energy. So in order of decreasing frequency and energy, we can start with gamma. Remember, when we were looking at the order based on decreasing wavelength, we started with radio waves. But now we are saying in order of decreasing frequency and energy, all right, we can start with gamma rays, followed by X-rays, then UV radiations, visible light, infrared, microwaves, and radio waves. So this order is in order of decreasing frequency. meaning that gamma rays have higher frequency than X-rays, and the X-rays have higher frequency than X-rays have higher frequency than ultraviolet radiations, and ultraviolet radiations have higher frequency than visible light, and so on and so forth. Very important to note that. So in case they ask you in an exam to arrange the radiations in order of decreasing frequencies, you start with gamma, X-rays, UV radiation, visible light, infrared, microwaves, and the radio waves. It also follows that as you move from radio waves to gamma upwards, this is the order of increasing frequency. So radio waves, microwaves, infrared, visible light, UV radiation, X-rays going upwards to gamma, the frequency increases. But also the energy, their energies increases. So in order of decreasing amount of energy, you can start from gamma pointing down. This means energy decreases. So gamma has higher energy than X-rays, and X-rays have higher energy than UV radiation, and the UV radiation have higher energy than visible light, and so on and so forth. Alright, so the lower you go down through this list, the smaller the energy becomes. So you can see here that the frequency and the energy of the waves are directly proportional, meaning the higher the frequency, the higher would be the energy content. Alright, okay, so remember, before we grouped them according to decreasing wavelength, and now we are saying we can have this another order for decreasing frequency. As we go down, frequency decreases. As you're going up, frequency increases, as well as energy increases. I hope so far so good. My name is Mr. Pochilola once again. Don't hesitate to subscribe to the channel so that you receive content as they are created and uploaded. What are the common properties of these electromagnetic waves? So these 7 electromagnetic waves have properties that are common to all of them. Alright, so we are saying all electromagnetic waves, including visible light. Visible light is like colors of the rainbow, the 7 colors of a rainbow. So including visible light have the following common properties. The first property is that they transfer energy. You are going to learn in future that this energy is given by E equals to hc, where c is the speed of light and h is a constant which is called Planck's constant. But this is not for you now. Right, so we are saying that all electromagnetic waves transfer energy. And the second property is that they are all transverse waves. They are all transverse waves. Remember that in a transverse wave, the direction of the vibration of a particle is perpendicular to the direction of travel of the wave. Just remind yourself what a transverse wave is. Okay, so in a transverse wave, particles vibrate perpendicularly to the direction of propagation of the wave. Okay, this is just by definition of transverse waves. Take note of the difference between the transverse waves and the longitudinal waves. You can review that from your Form 3 physics. Right? The third property is that they all travel at the same speed through a vacuum, and the speed is 3 million meters per second. Remember that 3 million meters per second can be written as 3 times 10 to the power 8 meters per second. Alright, in standard form. This is the speed of light, and every physics student is supposed to know this value of by heart, so that in case it's not given to you, you should be able to quote it and use it. Right. The fourth property is that they can all be refracted, and diffracted. Also, I would ask you to go through your Form 3 notes just to review the meanings of refraction, refraction, and the diffraction of waves. Okay, so they can all undergo these properties. Okay. You need to note that 3 million meters per second is the same as 186,000 miles per second. Of course, this addition may not be useful to you, but just for knowledge sake. And also note that through air, light and the other waves travel at about this above speed, but through denser substances, for example glass, the speed decreases. So we are saying even in air, these electromagnetic waves will travel at the same speed as quoted here, of 300 million meters per second, or 3 times 10 to the power 8 meters per second. Alright, according to Albert Einstein's theory of relativity, nothing can travel faster than the speed of light through a vacuum. Light is the fastest traveling, what can we call it? Maybe let's say substance, although light is not a substance. But later you are going to learn that light has a particle behavior. We call it dual nature of light. Okay, where light can behave like pure radiation, or it can also behave like a particle, which is called a photon. But that's a subject matter for the future. Alright, so these are the properties that are common to all electromagnetic waves. Alright, and additionally, you learned about the wave equation. All these waves are also respective of the wave equation, which says speed of a wave is equal to the frequency of a wave multiplied by its wavelength. Alright, so make sure you know all of these so that you can state any two when required in an exam. Right, that's very, very important. Alright, so I'm going to leave you with a question which relates the wave equation to this topic. Remember, the wave equation says that v speed of the wave is equal to its frequency multiplied by its wavelength. So in this case, you are told that you are asked to calculate the wavelength of a radio wave of frequency 100 meters, meaning 100 megahertz, if its speed is 300 million meters per second. So I want to leave you with this question to work on, and please share your response to the number given on the screen earlier on. But in case you forgot, you can send me the answer to 088-434-1022. That's where you can send your answers to. We meet again in lesson number 2 of the same topic, where we are going to look at other aspects of electromagnetic waves. Once again, my name is Mr. Pochilola. I wish you a very beautiful day, the rest of the day, and hopefully I'll meet you again. For now, remember to subscribe to the channel so that you get updates of the material as they are being uploaded. For now, bye-bye.